4.4, you're going to learn two more things about a triangle, one of which you've done before. You've done these ones a whole lot, altitudes, but medians you probably haven't, and so we need to talk about what those are and what they create when you deal with them in a triangle. The first thing that I want to point out to you is that worksheet 4 is a bit longer than some of your other worksheets, because there's a lot of review questions. One thing I like about worksheet 4 is that you will have to use some things from worksheet 1A and worksheet 2 and worksheet 3 and to be able to answer it, which is a good thing for a lot of you, so that you don't just think, oh, what am I learning now, and only learn about now instead of trying to remember what's in the unit. This is a lot better for you to remember everything in the unit when we spiral in questions from other sections. I like that a lot better. The first thing that you're going to learn is something called the median. The median is a segment that goes from a vertex to a midpoint on the other side. It is not a perpendicular bisector. It is not an angle bisector. These angles are not the same as each other. The only thing that this median is it goes from a vertex to a midpoint, and therefore it is a median. Medians, if you were to draw all three medians from the vertex to the midpoint, from the vertex to the midpoint, and from the vertex to the midpoint, it would look something like this. As a matter of fact, earlier while you were taking notes, I drew one myself. Here's a triangle. Let me turn the light on for you. And I measured this side, and I found the midpoint. I made a dot, and I drew a line from there to the dot. And then I measured this side with a ruler, and I divided it by 2, and I found the midpoint, and I drew a line from the corner to the midpoint, and so on. These are the medians that cross each other. The three medians are concurrent, meaning all three will connect at the same point. That point where they all connect is called the centroid. The centroid is different than the circumcenter or the incenter. What's interesting about the centroid is it's the balancing point. Literally, if I know where this is on a triangle, that point right there is the point where this triangle will balance on. Here's a pencil, and here is this. Let me see if I can show you this. I'm going to show it to you here underneath the camera, and then I'll show it to you live. If I do this right, and I get to that centroid right on top of this pencil, let me see if I can do it this way. Whoa. I don't know if you can see that on the camera. I'm going to hold it up here for those of you in the classroom. There you go. You see that right there? That little point where those three things cross is the balancing point. If you put your pencil underneath a triangle's medians that they cross, that is the balancing point. Kind of a neat little idea. You will not have to do that. You can feel free to do that on your own time if you want to. But what we're going to do primarily is we're going to deal with problems with centroids because they're the balancing point. They break up the median into a 1/3 to 2/3 ratio. Meaning this shorter piece from the centroid to the side is 1/3 of the whole thing. And this is 2/3 of the whole thing. This is 1/3 of the whole thing. This is 2/3 of the whole thing. This is twice as big as this. It's 1 to 2. 1 part to 2 parts, or 2/3 of the whole thing and 1/3 of the whole thing. We can do a bunch of problems that deal with that with a centroid. That's what we're going to do the math with. The second idea that you're going to have to know is something called an altitude. Altitudes are perpendicular segments to the line containing the opposite side that goes through the vertex. Meaning if I go through the vertex and I am perpendicular to this side, this is an altitude. It's not a median, it's not an angle bisector, it's not a perpendicular bisector. It's an altitude. When you do all three altitudes of a triangle, those things cross in some place called the orthocenter. The orthocenter is the most useless of these four ideas. When I think about the circumcenter, the incenter, and the centroid, there is a specific property about circumcenters. I can draw a circle that goes through all three corners. I know what the incenter is. It makes a circle inside. I know the medians. That's the balancing point, the 1/3 and the 2/3. But the orthocenter, when you put all the altitudes that cross each other, there's no fun thing about this at all. There's nothing that's special about it other than this also has three lines that go through the same point. There you go. I don't know what to say about that. So that brings us to your worksheet. I'm not going to do all of the problems, but I have 12, 21, 22, and 29 picked out to do with you. We have 4 examples. If you want to do this on your worksheet, feel free to do so. Number 12. Is MN a median, an altitude, or neither? It's a median if it goes from the vertex to the midpoint on the other side. Do I see that this is a midpoint at all? It's not a median. Is it perpendicular to the outside? Is there? Nope. This is called an angle bisector, but of our 3 choices, we're going to say that it is neither right now. How come? Because it's an angle bisector. It cuts the angle into 2 equal pieces. How can we tell? It has that right there. Angle bisectors, if we were to do that on all 3 corners, creates the incenter. That's a main idea of this section. Number 21. Number 21 I picked out because it doesn't use the full triangle every single time. It says name an altitude in triangle CBU. So they don't want you to use the full triangle. They only want you to use the triangle CBU. They only want you to use this triangle right here. Let's call it the blue triangle. So an altitude is one that goes to the vertex and is perpendicular to one of the sides. I see only one altitude in this particular problem. There are 2 letters that are perpendicular and goes through the vertex. This right here is the altitude. How do I label it? Segment DU. Or segment UD. I would accept that as well. Pay attention to which triangle they're telling you to use. In some of the other problems, they might ask you for the big triangle or this triangle, and you'll have to pay attention because there's a different answer depending on the triangle. 22 is my next example. This is where we're going to deal with a centroid. Oh, it's a centroid. What does that mean? That means that we go from a vertex to the midpoint on the opposite side. From the vertex to the midpoint on the opposite side. These 2 things have to be congruent to each other. From a vertex to the midpoint on the opposite side. It should look something like that. When it says centroid, it means that. Now what they're going to do is they're going to tell you something like DZ. DZ, this full thing is 12 units. You're going to have to find ZA, AD, and describe the relationship between ZA and DZ. This whole thing, DZ, is 12. Earlier, I told you that the centroid is the splitting point between 1/3 and 2/3. That this is 1/3 of the whole thing, and this is 2/3 of the whole thing. It's in 1 parts to 2 parts. If you don't know how to deal with fractions, then what you should do is write down 1/3 of the whole thing. This is 2/3 of the whole thing. 2/3 of 12. 1/3 of 12. And for those of you who are good with fractions, you just do 12 divided by 3. 12 divided by 3 is how many? Is what? That's what AD is equal to. 4. Now, if you are not good with fractions, use your calculator, because calculators can do the fractions and multiply by that number. I'll give you an example. If I'm doing 2/3 times 12, I literally can press the fraction button. 2/3 times 12. And I can figure out what it is. Or you could do 3 goes into 12, 4 times 2 times 4 gives you that AZ is 8. And if you'll notice, 4 is 1/3 of 12. 8 is 2/3 of 12. This is 2 to 1. 2 parts bigger, twice as big as this, as it should be. What are they asking? ZA is blank of DZ. How much of ZA is blank of DZ? What could I do to multiply DZ to make these two things equal to each other? ZA is how much of DZ? I hope you see it's 2/3 of DZ. 1/3 to 2/3. 1/3 to 2/3. Last example. 29. It's a review question. This isn't even from this section. This goes back to 4.1b, if you did not know. 4.1b, we learned something called a mid-segment. That's what this is. I know it's a mid-segment because it has a midpoint and a midpoint, and another midpoint and a midpoint, and 2 pieces are congruent. It goes from a midpoint to another midpoint. Mid-segments are half of the side they're parallel to. If this is 18, then you should know how long this mid-segment is. If this is 18, this is what number? Say it out loud. 9. Well, how do we figure out what x is? Well, you take the 2x plus 1, and it's supposed to be equal to 9, and then we can solve that to figure out how long x is. Do a little bit of math. The x is equal to 4. That's all they ask you to find. Find the value of x. But don't forget, you still have to use some things from previous sections. I hope that helps you as you start to do this worksheet. We'll stop your notes right there.